Good evening, everyone, and welcome to Sky Observers Hangout. It is so wonderful to have you with us here today. My name is Michelle, and I'm the Director of Public Observing at the Adler Planetarium in Chicago, and joining me is...
I am Hunter Miller, Public Observing Educator here at the Adler Planetarium, and really excited to be joining you for a special episode of Sky Observers Hangout. Taking a look up at the sky tonight.
Yes, and it is clear again.
I know, it's remarkable. We've had a really good string of weather for Sky Observers Hangouts. That'll always get us excited to start off. You know, doing the actual observing is always what we're here for. And I also wanted to mention a couple of folks that we have helping us behind the scenes tonight. So in the chat today, you'll see our YouTube chat moderator. That's gonna be Bella tonight. If you see the Adler's name highlighted in yellow, that's Bella. Bella will be helping us pass along any questions, comments that you all have during the show tonight, passing those along to us. So make sure to be typing those away in the chat. Also helping us answer some of the extra tough questions is our astronomer friend Geza. He'll be there. You will see a blue wrench next to his name in the chat. So he'll be a really valuable resource for those really tough questions you all have for us tonight.
And we are just so grateful that you decided to gather with us to nerd out about the sky, and that's what Sky Observers Hangout is all about. If you want to just sit back and watch, that is totally fine. But if you also want to interact with us, please go ahead and put your comments, put your questions in the chat. Geza will answer some of those, and Bella's gonna feed us some of those questions. So we may very well answer one or more of your questions in the show. And we have Bella telling us where folks are tuning in.
I know,
from.
we haven't even asked him yet where they're tuning in from. I think people are starting to get a feel for the run of things around here.
I think so.
We love hearing where everybody's tuning in from tonight, so keep posting those in the chat. And while you do that, I wanted to mention a couple of ways that you can stay up to date with not only all things Sky Observers Hangout, but all things astronomy and Adler Planetarium. Hitting subscribe to our YouTube channel down below. That'll give you notifications whenever we're going live for Sky Observers Hangout, but also get you all of the really awesome astronomy content that we have on there. I mean, that covers a lot of the important things I wanted to talk about at the beginning, but of course, the most important thing is going to be watching this eclipse tonight. And it looks like we've got lots of folks watching with us, tuning in from all over the world tonight, Michelle. Melbourne, Australia.
Hello, Melbourne.
Melbourne, that's definitely one of our furthest away viewers tonight, I imagine.
I think you win.
And we've got, lots of folks around the US too. Arizona, Texas, here in Chicago, New York City, Arkansas, Columbus, Ohio, Virginia, another Australia, Gold Coast, Australia,
Coast.
not so far from there, yep. And then another international friend joining us, Buenos Aires, Argentina, who you will have some important information coming later on in the show, so stick around. Costa Rica as well.
Oh my
Lots
gosh.
of fun folks joining us tonight, so it is so great to hear that we'll have so many friends doing some observing with us. A couple of Argentinians here today.
Oh, that's
How
awesome.
exciting. We did have one other set of friends that we wanted to give a shout out to.
Yes.
Which I will pull up here.
Humongous shout out to all of our friends down at Southern Illinois University, Carbondale. And we know you're there, we know you're watching. So thank you so much for joining us. And we've got a bunch of friends down there, and you will be down there in person in October.
Yeah,
so
not too far.
SIU Carbondale has a star party coming up. We're gonna talk about that during the show. But we've got friends from NASA who join us from time to time on our shows and help us out with putting stuff together. One of the things we wanted to mention is currently right now, it doesn't sound like it's a connection to the moon, but it kind of is. This currently is the Heliophysics big year. And so what does that mean? All sorts of folks are paying attention to the sun. Did anyone pay attention to the sun last night? Anyone see the auroras last night? They were faint, but they were visible all the way down to the Texas Panhandle. So I did get a glimpse of them via my phone. I couldn't see them with my eyes, but I saw them with my phone in the Chicago suburbs last night. So basically the sun is very active, and so there's a chance of potentially seeing auroras if the sun is particularly active or active enough over the next several months. And so last night was not your only chance to be able to see auroras, we hope. So all sorts of folks focused, on the sun. But without the sun, we wouldn't be able to see the moon.
Yeah.
So we're going to
Or be able to tell that it was being cast under the shadow of the Earth, right?
Exactly.
So a very essential piece of the eclipse puzzle, right? Whether it's a solar or a lunar eclipse.
Yep.
And we wanted to give that shout out as the big year is approaching its end here. I included a picture of the Parker Solar Probe, whose close approach will be happening in December.
Yep.
And that will kind of be the culmination of this big year of heliophysics that we've been doing,
Yep.
especially with all of the solar eclipses that we've had crossing through the states here, right?
So again, another hello to Southern Illinois University Carbondale and everyone else joining us. And so we've got a few more. We've got another Australia, Canberra. We've got the Dominican Republic. We have India. We have Brazil. Oh my gosh.
I know.
It's
This is
amazing.
a really international crowd today. It's so
Yes.
exciting to see. And I think that is a really great segue into starting to talk about our main topic for the night, which I'm sure if all of you are here at the stream, you're well familiar with. But we're going to be taking a look at a lunar eclipse tonight. And the fact that we have folks joining from so many different places is wonderful, because we're going to be able to see this lunar eclipse from a lot of the places that we've mentioned so far.
Including Minnesota and Utah.
Including Minnesota and Utah, the newest additions to the list there. I was going to say, I thought I saw an Arkansas earlier too, but I think we mentioned that one. Germany as well. So tons of places that we're visiting from. So we always love to start our show before the partial lunar eclipse really gets started here tonight with talking a little bit about how you, the viewers, can observe this at home too, right? Because especially with something like a lunar eclipse, this is one that doesn't require any, special high-tech gadgets to be able to observe. We're using the big telescope behind us tonight, but that's totally not necessary, right? The moon is so nice and big and bright in the sky that anybody that can get outside and look up and see the moon on a regular night will have the opportunity to check out this eclipse. So I want to start off with taking a look at a map of where this lunar eclipse is going to be visible tonight. And actually, it's a much bigger area than folks might expect. So can you break down this map a little bit that we're seeing here, Michelle? What did some of these different colors on the map indicate here?
So basically what the colors refer to are where you're going to see the eclipse in when the moon is passing through the dark part of the Earth's shadow, where you're going to see that in its entirety. And then on the edges, where you would see it as the moon is setting in the sky, or you might see the moon rising in the sky. So that's what those particular edge areas. If you're located in an area that is not colored in purple in any way on this map, you're not going to be able to see this directly, because the moon will not be up for you while this eclipse is occurring. But basically, how this works is the moon is going to be passing through just a bit. It's going to skim the dark part of the Earth's shadow, starting for all of us who are going to be able to see it in
just 7 minutes
in
here.
about in about 4 minutes. So 9:12 p.m. Central Time, which means 10:12 p.m. Eastern Time, which means 8:12 p.m. Mountain Time, and so on and so on and so on.
Yeah,
so,
getting the timing exactly right is important, but as you said, it's happening in the same moment for all of us. So if you're here in the live stream watching with us, then you'll be starting right alongside us. Now, I did see that somebody in the chat asked, can you tell us what we should be looking for when we're taking a look tonight? And actually, I think we should just go ahead to looking at what we should be looking for, because honestly, here in the camera view, I think we're already really starting to see a bit of a dip into the shadow, right?
Yep.
So, what you should be looking for tonight when you're looking up at the moon. Now, I will say this is a pretty minor partial eclipse. The moon will only be dipping just a little bit into the shadow that the Earth is casting out into space, right? So you won't be looking for a big, really dark and often kind of reddish tinted moon that you see during a total lunar eclipse. We'll just see a little sliver cut off. So you can start to see this in the telescope view that we have pulled up here live right now. So this is a view through the Dome Observatory telescope. The camera's hooked up right up here. You might be able to see that just up at the tippy top of our, in our camera view here right now. But through there you can start to see the moon beginning to be cast under a little bit of this shadow. You can see this darker kind of corner of it. Now, today the moon is a full moon, right? We only get eclipses when it is full. So we aren't getting that cast from something like maybe it being at a lower phase, right? A different phase, something like that. That is actually the shadow of the Earth being cast onto the moon.
Yep.
Now, by the time we get to the maximum partial eclipse at around 9:45, this is what we can expect to see here. So this is also an image from Time and Date, which Bella should have will have linked in the chat there on YouTube for you to check out. That'll show you information about your individual location for the eclipse tonight. You'll see this is a really, really partial lunar eclipse. So the magnitude that we have indicated here is just 0.08. You might be wondering what that means. That means that the shadow of the Earth is going 8% across the diameter of the moon. So what I was wondering is that, I said, 8%, there's still a lot of bright moon there. This equates to only about 3 to 4% of the total moon being covered in shadow. So a really brief little dip into a lunar eclipse that we're looking at today, which is why we wanted to really zoom in on that part through the big telescope.
So the moon, as it orbits the Earth, usually the moon's orbit is tilted a bit with respect to the Earth. And so normally the moon either passes above the Earth's shadow or below it. But when you have everything lining up just right, it'll pass through the Earth's shadow. Now that does not mean necessarily that it passes through the entire Earth's shadow, or that the entire moon passes completely into the Earth's shadow. Sometimes it just skims it. Like what happened in March. So there was a lunar eclipse associated with the solar eclipse. That one, when the moon went through the Earth's shadow, it only went through the very lighter outer part. You basically could hardly tell there was an eclipse happening in the first place.
Right.
So we didn't really pay a lot of attention to that one. This one, the moon is passing through that lighter outer shadow and a little bit of the darker inner shadow. So that's where you're just going to see, in about half an hour or so, you're going to see the what looks like a little bite taken out.
A little sliver
Yep.
out of that corner edge.
Exactly.
And actually from this image from Time and Date, it actually indicates these white circles that are showing, where the Earth's shadow is being cast. So you can see that dark inner shadow is just clipping the moon there.
Yep.
And most of it is within this kind of outer dim part.
So if you go to the live view, it is 9:12 p.m. Central Time, where we are. And I have not adjusted the light levels on the camera on the telescope at all. What you're seeing, that darkness over there to the upper right on your screen, that is the actual shadow of the Earth that the moon is starting to pass over. If it wasn't there, this whole area would be bright. So you're actually getting a bit of the shadow. Now, how can I prove that this is a live view? This is the controller that I use to move the telescope. So I'm gonna bump it slightly. So I'm gonna go, let's see, we'll go this way.
It's always a little bit of a mystery which direction it's gonna move.
Whoops, maybe I have to actually wake it up.
There you go.
Then,
Not working today?
wait, hang on.
I'm checking our settings. Oh, there we go. A little bit of a slow delay on it, but that's all right. We can make it work.
Then, let's see, I went that way, and let's go this way.
You might be wondering, it should be pretty straightforward. We move the control stick left. Our camera view moves left, right? Doesn't work out quite so easily, unfortunately, with telescopes. Inside, we've got, lots of big curved mirrors. This really gets into how telescopes work, right? So the way that telescopes function is, especially this one, this is a reflector telescope, so it functions using a large mirror in the back rather than lenses on the inside, right? So this has a large curved mirror. And I always compare this to when you look at yourself through a spoon, when you were younger. Now, that spoon wasn't a perfectly curved mirror, so it was a little extra distorted, but you might have also noticed that it might have ended up, showing you upside down or something like that. Same thing happens with the mirror in a telescope. Because that mirror is curved, it is flipping the image upside down, and we end up with all kinds of different directions that it moves when we move the joystick.
Can you tell I'm having fun?
And you know, it's really an issue we can't complain about. The telescope is too big for us to get the whole moon in at once, right?
Oh darn.
Oh darn, exactly. And so we thought that was rather intuitive for tonight, since the partial eclipse was so minor that we were dealing with today. Now, while Michelle's getting us centered right on that spot, and ooh, look at that dark shadow starting to encroach across the moon. That looks great.
That's cool.
I wanted to mention some other questions that we had coming in the chat that I think are important to mention now. One being, do you need glasses to watch the eclipse? So especially with all the solar eclipses that we had recently, I think, you know, eclipse glasses have been particularly on the mind. Don't worry, don't need those for tonight. Those aren't particular to eclipses. Those are instead particular to looking directly at the sun, right? So even when an eclipse is not happening, the sun is much too bright for us to look at with the naked eye, right? And so that is what those eclipse glasses are helping with. They're really just solar viewing glasses, and they're dimming the light so that you can safely look at the sun. Most of the time, we don't have the inclination to look directly at the sun, right? But during a solar eclipse, of course, we're a little bit more focused at looking on it. Nothing to worry about during a lunar eclipse. It's just as bright as the normal moon, so no issues at all.
And one other thing is, think of it this way. If you normally can look at the moon with just your eyes, we're actually making the moon a little darker. So you absolutely do not want to put on a pair of solar glasses or anything like that. The moon is already going to be dark enough. One thing that I'm going to go do is adjust the light levels on the camera. So my computer for doing that is over here. So I'm going to go behind here, and you're going to see. And Hunter's gonna keep talking.
All right, yeah, I'm gonna answer a couple of other good questions that we have in the chat here. So one person's outside now, which I love to hear. This is something we always wanna encourage is, while it's wonderful to observe through our telescope, seeing it with your own eyes is the most important thing to us. So make sure you're taking the stream outside with you and checking out the lunar eclipse with your own eyes, because if the moon's up where you are right now, you can see this happening. Somebody said they're outside now and they see the shadow in the top left, not the top right corner of the moon that we're showing. What's up with that? So this gets down to those same curved mirrors that I was talking about earlier, with why it's difficult to get it exactly centered and why the controls might throw us off a little bit. So when we use telescopes, the images can be flipped upside down, they can be flipped side to side, they can flip in all sorts of different ways, depending on the arrangement of your mirrors, depending on how the camera is physically inserted into the focuser that we have right now. When it comes to astronomy stuff, we don't worry too much about images being flipped upside down or different directions. We could always correct for that, but it is going to require more pieces of glass, and we want to collect as much light as possible, right? We want as little pieces as we need to get that good view. So we don't worry about the image being flipped, so it might be a different view than you're seeing tonight. It also depends on where you are, which direction exactly the moon will be tilted, because that changes depending on, you know, where it is on the horizon, or if we have, like some of the folks that are joining us from down in South America today, they would see the moon totally flipped upside down from how we were seeing it. So it would be on the bottom corner of it rather than the top corner like we're seeing here in the Northern Hemisphere. So there's lots of different ways that you might be expecting to see this tonight. If you utilize that time and date website that we mentioned earlier and you put in your exact location, it will show you a accurate view of the moon based on your location tonight. And so if you want to know exactly which part to look at, then you can utilize that website and check it out. But you know, if you see the sliver getting taken out of the moon, then you know you're seeing that eclipse happen.
There's a really great question that I'm seeing that Bella fed us, which is, why does the moon look red during the eclipse? This particular eclipse will not look red. And it's because the moon is not going to go completely into the shadow cast by the Earth. But we can talk about really briefly about what causes even that to happen in the first place.
Right.
So why does it happen?
Yeah, so what we're going to be seeing here tonight is just going to be a partial lunar eclipse. Now, this is not from today. This is an older image from, I can't remember exactly which one in 2022, but one of the lunar eclipses that happened then. Maybe the one earlier in the year, like in the springtime, I think. Either way, this is from an eclipse, a lunar eclipse from back in 2022. This is more similar to the view we'll expect to see tonight. This is a little deeper into the partial phase than we'll make it to, but right, you can see that chunk being started to take out of it. Now, once we reach a total lunar eclipse, the view gets very different, right? Now in this image, we see the moon turning this red hue that they were mentioning in that question. Now this occurs when we get the total lunar eclipse, when the moon is completely cast under this dark part of the Earth's shadow. And what's happening to make it red? Why that red color rather than it just turning dark gray?
Right, so we're gonna get one of these eclipses in March. So, so stay tuned. This information may not be appropriate for this eclipse, but we're getting you ready for the total lunar eclipse happening in March. So what's happening is light from the sun hits the Earth, and it passes through the atmosphere at the very edge of the Earth. And as the sun's light passes through the atmosphere, the Earth's air, at the edge of the Earth, the blue wavelengths of light are scattered by our atmosphere. Well, of course, we see that every day. That's how we get a blue-looking sky, is the blue light from the sun is scattered out, making the sun actually look more yellow than it really is. But we've got the blue light scattered out, but there's enough air that the sunlight is passing through that even some more of the longer wavelengths of light are scattered out, leaving you with just this reddish, grayish, dusky color. And the color can change from one total lunar eclipse to the next. It all depends on how cloudy the atmosphere is at those particular locations at that point, how dusty, cloudy, clear, if it's hazy, if there's been a big volcanic eruption and there's a lot of dust in the air, all sorts of stuff. So there's a lot of things that can affect the color that you see. But primarily that all exists because sunlight shines through Earth's air, showing you essentially turning the color of the moon to be kind of like what you think the color of the sun looks like when it's down really close to the horizon and passing through a lot of air. So as we like to say, you're seeing the collective light of the sunrises and sunsets happening at that exact moment at those exact spots on the Earth.
Right.
Yep.
And you can imagine, you know, every sunrise and sunset doesn't look exactly the same, right from here on Earth even. And so that's where you get some of that color variation in the total lunar eclipses. And yeah, everybody that's watching tonight, you'll have to join us again in March when the total lunar eclipse comes around. You might have to stay up a little later for that one.
Yeah.
But it's worth it. The total lunar eclipses are really beautiful.
Definitely. And so, but that also goes into, I know Geza answered this question in the chat, but it bears repeating. How often do these eclipses happen? Well, you get a lunar eclipse associated with a solar eclipse. And so, but not everybody who gets to see the lunar eclipse gets to see the solar and vice versa. So you don't necessarily have the same spots on Earth able to see that, and there's reasons for that. But you get about 1 or 2 lunar eclipses a year on average. Solar eclipses, you can get 1, 2. There are even a bare handful of years where you might get 5 solar eclipses in 1 year. Can you imagine? The last time that happened was 1936. It's not going to happen anytime soon. But you definitely have these eclipses occurring about once or twice a year. But again, not everybody gets to see them. You notice that not the entire planet gets to see the lunar eclipse. It just happens to be the side of the Earth, or that happens to be facing the moon. So the moon's up in the sky during that hour when the lunar eclipse is occurring. So we're pretty lucky to see this.
Wanted to give a couple of eclipse updates. We're about 10 minutes in now, only 20 minutes out from the maximum, and we actually have a couple of views we can offer. So I wanted to go back to our observatory view that we have going right now. But I also wanted to note that, well, there's one other person helping us behind the scenes of the show tonight, who is right over here.
Can we have him come and wave hi? Dylan, you want to come wave hi? We have a new family member here, folks. So this is Dylan. There he is. And he just joined us about a month ago. So he's from our theaters department here at the Adler. He's been here a couple years. He knows his way around, but he is brand new to the public observing team. So you're going to see him on Sky Observers Hangout in the future. And if you come here to the Adler tomorrow night with the observatory open, you'll see him here in person. So anyway, he is feeding us. Cool. Did you just take this image?
Yes, so
That's cool.
Dylan is outside working with our
cool.
Sea-Star telescope, and actually this answers a wonderful question. Why aren't we showing a further out view tonight? So we wanted to utilize the big dome telescope that we have, since this was such a partial view, but we also have one of our new telescopes added to our arsenal of telescopes that we utilize out here. This is one of the new sort of family of smart telescopes, the ZWO Sea-Star S50. And so he'll be getting us some slightly more wide field views of the eclipse as we continue on tonight.
And he is literally taking the pictures. He is about, what,
10 feet away from us.
He's about 10 feet from us with the Sea-Star outside on a little deck we've got right here. And he is taking the pictures, dropping them into our slideshow. So these are almost exactly live.
Almost live, yeah.
Almost.
Just a couple of minutes behind,
yeah.
you know. But this gives you a good idea of what you'll be seeing with your eyeballs up in the sky, right? This has certainly more detail than you would see naked eye, but it gives you an idea of what kind of chunk you're going to see taking out of the moon. Quite a noticeable one. And actually, I'm looking at it with my naked eye for the first time so far, and you can definitely make it out here. I'll lean back so you can lean back too and see it if you want to make it out.
So I got, oh, that's
see it
cool.
back there?
Yep.
You can see a pretty decent chunk already. That was actually, honestly, more clear than I thought this little teeny eclipse was gonna look, if I'm gonna be honest. I wasn't sure how much this would...
One thing I need to do is I need to move the roof a little bit. So
all right, so
it's gonna get a little loud.
The telescope that we have tracks the objects that we are looking at throughout the night. But the roof itself does not track with it, so we have to adjust every once in a while. So apologies for the noise here, folks.
1, 2, 3.
All right, I killed the sound for a second to make sure it wasn't too loud. Yes, that looks great.
Good. Go.
All right, another question that I see. Will I see it from Ireland?
Yeah, go out.
Absolutely,
Hey,
go outside. If you can see the moon, you can see the eclipse right now.
Yeah.
So as long as it's clear there in Ireland, I don't know how often you get clear skies there, but yes, you can see it in Ireland right now if you're there. And I saw a few other folks posting from some other fun faraway places. We had people joining us from Lebanon, Syria, Tokyo, Greenland tonight. So tons of folks observing this eclipse with us. And actually, I will go ahead and go back to our live observatory view tonight. So yes, if you are in Ireland, go outside, check that moon out in the sky.
So I'm moving the telescope in the wrong direction, so I'm gonna go back the other way. So you can see the bright area there. That's the part that is not within the dark part of the shadow. Mm-hmm. And here we go over, actually I'm kind of glad I moved it over to the bright area, so then you can actually see the difference between those two spots, those two parts of the moon, very starkly. So that dark part in shadow right there on the upper right hand portion of the screen, that is the dark part, the moon that is in the darker part of the Earth's shadow right now.
So one question, I apologize that we didn't answer this earlier. I hope that the person that asked it is still hanging around, but because this has been something that I've seen in the news a lot recently, I did want to mention it anyways. The question was, is there a satellite orbiting the moon like an asteroid, I heard? And so what I think this is referring to is what I've seen the news sort of portray it as is sort of a second moon that the Earth will have for a little bit here coming up. And what this really is an asteroid that is coming close enough to the Earth to be influenced by our gravitational orbit enough that it will make a few orbits around the Earth and sort of orbit around us like a moon. Now, one thing that I did want to mention, because I know a lot of these news stories have made it sound like we're going to have this new big moon in the sky that's going to be really visible. The brightest this asteroid will ever get is, I believe, around magnitude 17 when it's at its closest to Earth. That is nearing the limits of this telescope with a camera hooked up. So with our eyeballs up to this telescope, we're closer to like the, I don't know, maybe 10 to 12 range is usually what we say. Yeah, around 10. We haven't tested our absolute limits on like a perfect seeing night. So magnitude 17 is far beyond its capabilities, and it would require a long exposure photograph to really see that through this telescope. So yes, technically there will be an asteroid that will be orbiting around us like our moon does, but it will be very, very small and overall more insignificant than maybe the number of articles it has received. So I wanted to answer that question because I had seen it had been mentioned in the chat earlier, and I have seen a lot of stuff about it recently.
Yep, and this does happen from time to time. So it won't be a permanent fixture in our sky. And that 17th magnitude level, that's what we can get with this telescope if we point it at something and stare at it for 2 minutes.
Right. And all that comes out is a little dot that looks like a star, right? Not any detail like we are seeing with the moon tonight.
Right.
A couple other comments coming in that I wanted to mention. Somebody had a successful time viewing it with some binoculars there in Brooklyn. Anybody that's got binoculars out tonight, that is a great tool for doing some lunar observing or even other kinds of astronomical observing. I know that, sorry, I saw some other messages coming in that made me laugh. Binoculars are a great tool.
I want 2 moons, so do we!
Having 2 moons would be awesome. Or, those lucky ducks up on Saturn or Jupiter that have, dozens and dozens of them. But awesome to see that folks are getting out, observing it where they are. I hope everybody has as clear skies as we do tonight. We have another really, really good question here. What makes a telescope better for lunar or planetary observing versus deep sky objects? Planets seem more fun is what they mentioned. Well, you're in luck if planets seem more fun to you. Those are much easier to observe than deep sky objects. With deep sky objects, I would say, honestly, the bigger the better, because they get really dim really fast, right? You get to these distant objects, these really diffuse things, like, maybe these different nebula that are out there, or even objects like faraway star clusters or other galaxies. Those, it's all about collecting as much light as possible. And the bigger the telescope, the better. So this one is really, really well suited for that. You can do it with much less, of course, but it does honestly take a lot more practice. Lunar or planetary observing is much more manageable. I mean, your first lunar observing tool is just your set of eyeballs, maybe a pair of glasses if you need them like I do. But then you can kind of graduate up to other things like getting some binoculars is a good one, or even a really small starter telescope will be wonderful for observing things like planets and the moon.
Basically, you need enough light to be gathered by the telescope to activate the sensors in your eyes, essentially. And planets are just brighter and they're extended, and so they're just easier to see. And you don't need a huge telescope in order to see something like planets, whereas some of those darker or dimmer, deeper sky, we call it deeper sky objects, like the stuff that's distant, that is relatively faint. Mm-hmm. And you don't have a lot of light impacting your eyes to be able to see that stuff. So you need a bigger telescope in order to do that. So a small telescope, a little 2¼ inch diameter telescope, lens or mirror diameter, you'll see rings. You'll see that Saturn has rings. You'll see up to 4 moons of Jupiter. You'll see a few different things, but you won't see some of these really dim, deep sky objects because the telescope just isn't gathering enough light to then have your eyes be able to see that stuff. Whereas that's where something like this telescope here, which is 24 inches across, right, that allows us to be able to see that dimmer stuff a lot more easily.
Exactly. Another question that we had coming in, does the eclipse affect the Earth? Now, the eclipse won't have any sort of direct impact on the Earth. There won't be any influences on the Earth because of the eclipse occurring. Of course, the Earth is a very essential part of the eclipse happening, right? It is the shadow of the Earth that is being cast on the moon that is making this visible. So it is a very, very essential part of it.
So I'm going to do one quick thing. Hang on. Wait a minute.
So over there, when you see Michelle heading back here, that is our computer for controlling the telescope.
Yep.
Getting you a little bit of a bigger view of the moon tonight.
There we go.
Thank you, Michelle.
No problem. So there isn't a direct effect on the Earth for the lunar eclipse. However, what's going on the Earth can affect how the eclipse looks.
Right.
Yeah. So either the dustiness or clearness or whatever, I just made up that word, clearness, of the Earth's atmosphere. But also, has the sun been particularly active? Has it heated up the upper parts of the Earth's atmosphere? Is the atmosphere puffing out a little bit more? If so, the shadow region might be a little tiny bit bigger. And so you might get, you can start to figure out what the upper reaches of the Earth's atmosphere are doing by watching the timing of the shadow across certain craters. Now, this particular eclipse isn't crossing any major, larger craters. It's just not that much of a deep eclipse to be able to do that. But that is something that they watch, and so they watch and time when the shadow crosses certain craters and how long it takes to do that, and that tells us more about the puffiness of the Earth's atmosphere, which is affected by the sun and the sun's activity level. By the way, I know we've got some comments about showing full screen. This is full screen.
So, made it a little bigger. One thing that we always say, I think, is a mantra with Sky Observers Hangout is, we're here to show you the live views that we're getting, right here in time, and we're not afraid to show a little bit of the behind the scenes.
Yep.
And to really be able to show this good live view, we do have to have some of those additional controls up and things so that we can alter the image and make sure that you're getting the best view that we can get tonight.
Yep.
And so you might see a few, settings on the side. I do apologize for those. But that's a little bit of kind of what we do out here,
Yeah.
This is you're really getting exactly what we're getting out here. This is a really, really direct way, a look inside our observatory here at the Adler Planetarium.
Cool. So do we have? Hey, Dylan, how you doing?
Doing good. Lost connection. We'll get there.
Okay, sounds good.
So Dylan's gonna try to get another image for us. So, but the eclipse in the big telescope, the reason can we zoom out? No, we can't, because it's a big telescope, and so this big telescope shows you a smaller piece of sky. The bigger the telescope is, the smaller the piece of sky is that you're looking at. And so that's why we have a 24-inch telescope, and it's showing you about a third of the moon right now. Whereas the C-STAR telescope that Dylan is working with, he has a much smaller telescope. It's only about this big, about 2 inches across is the main lens for that telescope. So that's why that one can show the whole moon. And so is that the image that's up right now? So
yeah, so this is the one from earlier, but I will say, it doesn't look so much different to the eye. You've still got just a little dip into the shadow.
Yeah, that's pretty cool.
Yeah, sorry if you see us peeking out. There's a little slot where we can still see it out there. Hard part of running these shows is we don't get to look straight at these objects on our own, right?
For once, it's bright enough. And if you're seeing me keep doing this to my hair, it's because there's a breeze coming in off Lake Michigan. So I'm down to just a bad hair night for this particular show.
Well, I love hearing a few comments here in the chat saying that started in New York. They've got clear skies in Dallas. Lots of folks that are able to observe this eclipse tonight, because that is, of course, always what we're hoping for, is that you guys are all looking at it with us.
Hey, we got a couple more people. Did you mention Tokyo and Greenland?
I know, and Mexico City's new as well. Yeah.
Oh, hey guys.
So great to hear everyone joining in from so many faraway places. I hope that you're outside checking out the moon as well.
Basically, if the moon is up for you right now, go outside. Take us with you outside. Take your phone out and go out and look at the eclipse. If it's clear out, you can see this. You don't need anything special. Just go outside. You just need your eyeballs. And if it's cloudy where you are, thank you for joining us. That is really awesome. So, all right, we've got a few.
Yeah, you see this new question here? I think this is a really interesting one. So we'll start off with the first question. Are any of the large terrestrial telescopes able to see something small like the Apollo landing sites?
So the answer is no. The Apollo landing sites are small compared to the size of the moon. The lunar landers were, I don't know exactly how big across they are. Let's pretend it's 15 feet. Pretend they're 15 feet across. The moon is 2,000 miles in diameter.
Right.
You're having to pick out something 15 feet across from an object that is about 2,000 miles wide. So that's just not possible. Even something like you would think the biggest telescope on Earth, could it do it? Nope, there's just not enough resolution to be able to get down to something that small. Now, it does not mean we cannot take pictures of those sites. It means you just have to get closer in order to do it. And so there is a spacecraft called the Lunar Reconnaissance Orbiter that has taken pictures of the Apollo landing sites, and so they've got pictures from lunar orbit. But that's where you need to be.
That's
in order
from really, really close.
Yeah.
And I think to kind of emphasize that kind of point here. Of course, there are way bigger telescopes than the observatory. Although I will say ones that are much bigger than this frequently are not being pointed at the moon, right? These really large research telescopes have, tons of people competing for the time on them. And so I actually wanted to show some other pictures because, a full moon isn't necessarily the best time to observe some small lunar details, right? And so the reason for that is it's really uniformly lit. So I wanted to bring up some pictures from some past observations. Oh, sorry.
No, I'm good. I'm good. I'm just moving the telescope while he's talking. I'm just moving it a little bit.
And so this is a picture through the dome telescope, but you can see a lot of different kinds of details here. So rather than at full moon, this is at a less illuminated phase, and we're looking along what we would call the terminator, the line where the moon is going from illuminated to dark, right, in its phase. And so along that line, you can imagine it's like sunset or sunrise here on Earth, right? It's going from night to day on the moon. Well, what do we have at sunset and sunrise here? We've got really long shadows because of the angle that the sun is hitting us at. And so you can see, look at how much more detail you can make out in some of these craters and things on the moon. This was taken through the exact same camera using the exact same telescope, right? And you can see so much more detail. Actually, I had this picture to emphasize. These were taken on literally the exact same night. You can make out a lot more of the detail when you have that terminator to be able to look at. So this should be good encouragement for you to continue looking at the moon even after tonight. A lunar eclipse is great, but there's also tons more features that we can make out really clearly on all kinds of other phases. Now, even through these images where we can see a lot more details and a lot of these little craters popping out because of their shadows, the smallest ones we can make out through the dome telescope are still about 2 miles across. So we're never gonna see some of those really, really little objects like the Apollo landers or any of the tracks that they left behind, which the Lunar Reconnaissance Orbiter is able to spot from its place orbiting around the moon. I'm gonna switch back to our live view because I see Michelle was tweaking our settings here a little bit to brighten up some of that shadowed portion so we can see it better now.
So I adjusted the exposure time for the image to be about double what it was. So it was at about 10 milliseconds for one image. Now it's at about 20 milliseconds, 20 thousandths of a second. And so you can see that darker part of the moon in shadow there, and the lighter part is the part over to the left. So that's showing you a bit more about what we're able, what the telescope is able to see, but what the camera is also able to show us too. Where it might be a little too dark to see with just your eyes, we can adjust the light levels on the camera a bit to be able to bring that out. Oh my goodness, how many craters are on the moon? Wow.
Whew, should I go back to that last picture?
A lot.
Look at this picture, right? It is absolutely peppered with them.
Because not only are you looking at all these craters, you can have craters that are this big.
Right, these are the big craters on the moon, right?
Yeah.
There's also a whole nother side that we're not seeing, right? We always have the same face of the moon, or side of the moon facing towards us, right? So I don't know if we've really got an updated crater count for the moon. We might have a number of like the named craters, but there are so many on it. And you might be wondering, why does the moon have all of these craters that we don't seem to experience so many of them here on Earth, right? Well, here on Earth, we've got this wonderful atmosphere. Not only does it allow us to breathe, but it also protects us from interstellar potential fates.
Breathing is good.
Breathing's
That's good.
great, but also not getting smashed into is also great.
Also
so
good.
what is happening is, right, you've got all these rocks, traveling through space out there. Well, when they're coming towards us, right, there is nothing that they are going through and passing through space. They're unimpeded, right? It's just a big, empty sky out there. Just a heads up, guys, we're 1 minute away from maximum eclipse, so make sure if you're gonna pick one time to go outside, now is the time. It does look quite lovely up there behind us. And so here on Earth, right, when these rocks are coming towards us, it's hitting the atmosphere, and when it reaches the atmosphere, these rocks are moving incredibly fast, right? And there's all of this new friction here. You might not think that gas is really that much, but compared to, the emptiness of space, there's a lot of new stuff going on out there, right? Hits that, this ends up burning up a lot of these rocks up in the atmosphere, and what does make it down is usually pretty small pieces. We've also got lots of active geology that covers up from craters past, right? There have been some major impacts here on the Earth, but they get covered by all of this natural processes going on. The moon doesn't have so much of that, right? It doesn't have all of these gases around it. It also doesn't have a ton of active geology going on to get rid of those craters.
So basically, is it because of asteroids that hit the moon? Yes.
Yes, exactly. You got it exactly right.
And actually, you could say asteroids or meteoroids. Meteoroids are objects in space that are less than a meter in diameter. Asteroids are objects in space that are more than a meter in diameter. So anything from tiny little pebbles all the way up to big things have hit the moon. And asteroids, meteoroids, call it either one, then yes, they have hit the moon, left holes, and there's nothing there to wipe away those craters over time, except for more stuff that hits the moon.
Right.
So I'm gonna go adjust the light levels just a little bit more.
Yeah,
so
go for it. Get it positioned just right. And of course, if anybody has any other questions for us in the chat, make sure to pass those along. Just a reminder, we are actually currently just past the maximum for this partial lunar eclipse. So get outside if you haven't been out there already. We're seeing it really looks, I really wasn't sure before the total honesty moment right here. Before this show, I wasn't really sure what such a minor partial eclipse would look like in the sky, with such little obscuration that we were actually getting. But I'm actually pretty darn impressed with how it looks up there. It really is a nice view. So make sure you are getting out there and checking it out while you are watching us today.
Yep.
We love you being here with us, but more importantly, we want you out there with the moon,
Yep.
So, yes. So a question, kind of a follow-up to how many craters are on the moon. How often is the moon impacted? So we could get kind of a general amount over time, but if I'm gonna be honest, over the lifespan of the moon, that impact rate has really changed quite a bit. So in the early solar system, there were a lot more small objects out there. Well, there were a lot more big objects too. There was just a lot more stuff. The solar system's been around for a few billion years at this point, and it's a little more organized than we think it might have been in the far distant past, right? So these days, a lot of stuff has kind of found its place. It's orbiting around in these nice orbits that don't cross paths too much. Of course, there's some stuff that gets thrown out of that status quo, right, and comes towards us. But in general, there's a lot fewer impacts these days than there would have been in the past. Now, it is a great question about how often is the moon impacted. We do take a look at the number of craters on a surface, this cratering rate, to determine how old surfaces of a planet is. So we can use that for things like the moon, other moons around other planets, other rocky planets, places like, Mars or Mercury. So there's a lot of uses to seeing the number of craters, but it's hard to give an exact number on how often is the moon impacted. If I'm gonna be honest, we haven't made it to the point of really observing a lot of these impacts. There are plenty of amateurs who are recording videos of the moon and happen to catch one of the big ones, but it's not so often that we really get to see one of those happening.
Right, and it'll get hit by little stuff every day, but is that big enough to make a crater that we can see? Not really. It does happen from time to time, but not that often. But it definitely gets hit by little things.
Right.
So lots of little things, not too many big things. So I'm gonna go adjust the light levels on the camera again.
Another good question here. So why do all the craters seem to appear to be the same depth? You know, I would say that that really is just a case of our perspective and just, you know, how big the moon is versus how deep these craters go. There's a huge range to the different kind of craters that you're gonna see. And I actually think if I switch over here to this past image where we can see a lot more of the detail in the craters, that you can see a lot more variation in these craters when we get a really close, detailed view along that terminator. Here we can see a lot of depth variation. Some of them, like, I don't know if you guys can see my mouse here, but here right in the middle, you know, this one compared to this large one that has this big shadow being cast across it, those are really significant differences in depth, and we're seeing them from very far away, so I think that difference in depth is like an even bigger difference than what it really appears from here on Earth.
And one of the things that you'll also have to remember so if we want to switch back to the telescope view, so one of the things at full moon that you don't really see very well is any sense of how deep any of the craters are.
It's just all bright.
Yep, so the sunlight is shining straight at the moon, and so there's no relief visible. There's no bumpiness of the moon visible. Whereas if we were to point the telescope at the moon in a couple days or look at it a few days ago, at the edge where you see the shadow line, that's where you'll see the bumpiness of the craters. All the craters right now look very, very flat.
Right.
Because the sunlight is shining directly at them.
Really straight on.
Yep.
You know, it is midday for a lot of these places.
Yep.
There on the moon. And this gets to another question that we had. How does the moon reflect light? Well, it's helped by one very important bright object, of course, the sun. So this is all the sun's light that we're seeing reflected off of it. And depending on which part of the moon is illuminated by the sun, changes what phase we are seeing, right? So right now, the sun is illuminating the entire front part, other than, of course, the part that is going behind the Earth's shadow. And the moon reflects light just because of the kind of rocks that it is, right? Just like everything else reflects light, right? For us to be able to see any objects, that means that light is reflecting off of it. Now, the moon also is made of a lot of rocks that are pretty darn reflective, and it really helps make it appear brighter, right? These lighter colors,
Yep.
they really do a good job of reflecting it. But it's just, you know, just how rocks reflect light. That's all it is.
And what's actually not readily apparent is the moon is about as reflective as it's similar to asphalt. It's kind of weathered asphalt, you know, not the fresh stuff, not the really dark black stuff, but kind of the weathered, darkish gray type of asphalt. So it seems like it's incredibly bright and just it must be covered in ice or something like that. It's that bright. It's really not. It just looks like that because it's big and close.
Right, it's close in the sky. What's shining on it is really bright. That, of course, helps.
Yep.
But its closeness definitely makes a big difference. And it's, you know, think about what you're comparing it to, right? A really, really dark sky around it
Yep.
when you're out looking at it at night, right?
Yep.
Go out during the daytime when you've got a blue sky and try to catch, you know, try to see if you can locate the moon. And you might realize, oh, it's not so bright as I thought, because that can be a tough task sometimes. So why is the soil gray on the moon is another question that we had.
Oh. So
this really just comes down to the kind of rocks that are on the moon, right? That makes them gray. But you might also be wondering, you know, why is it so uniformly gray, right? There's a lot less geologic diversity on the moon than we have here on Earth, right? Rocks are being made from a ton of different methods, right? We've got all these different kinds of volcanic rocks, but we also have all of these different sedimentary rocks that are made from things like sand being compressed down or things like this, right? Or we've got dirt and plants all on the surface that obscure some of these different rocks. The moon, not quite as varied as we have here on Earth, and so that's why it looks so gray. And I will say the different colors of gray that you see are because of some of the different kinds of rocks that we'll see on there.
Yep.
So you might notice that, like, you'll see the large mare, those big dark gray patches on there. Those are a different kind of rock that appears a different gray.
So I'm just moving the telescope around a little bit, and if you're wondering why that part that I was just showing was very bright, it's because the camera is showing you the shadowed portion right now up on the upper part of the screen. And then the light levels for the rest of the moon are going to be off, and so they're going to be too bright. So it's kind of a toss-up. Do I want to show you the shadowed part, or do I want to show you the bright part? So just kind of have to kind of pick and choose what we want to show.
It's kind of like our camera right now. We've got this really bright screen over on the right side, which is washed out, and then, you know, really dark background over here.
And if you're wondering why we keep looking our main screen that we're looking at, I'm driving the telescope.
Right, it's because I'm trying to watch the lunar eclipse over here on the monitor.
I'm driving the telescope with this, looking at a screen here, which is actually that screen over there, which is from the camera, which is on the telescope right here. So this really is live.
I love some of the comments that we're seeing here. The moon almost looks like a gradient blue, or you see like an interesting halo around it. I saw a little bit of that blue kind of reflected light when I was looking earlier as well. You know, this really comes down to just how bright the full moon is. Of course, because we have because we've got a full moon going on right now and a lunar eclipse that has us particularly paying attention to the full moon, we're really noticing how bright it is. Now there could be some little effects from, it is technically a supermoon today. It's a little brighter than your average full moon. I don't know how much that really influences things, but some of those halos that you might see around it, or like, you know, a big ring of light much further out from the moon, could come down to like the atmospheric conditions around you. If it's kind of humid where you are, can happen. Oh, I just saw somebody just came back inside from viewing it with binoculars. Very cool. We love to hear it. Glad you kept the stream running. Came back in to get some more content from us. Thanks so much.
And by the way, I just adjusted the light levels so you can see the rest of the moon, and now you can see how shadowed that area really is. Up on our screen, it's on the upper right part. Again, telescopes flip images, so you might be seeing it on the upper left. We're seeing it on the...
For me, it's kind of, you know, with my eye, it's right on the top right now.
Yep.
And to give you an idea of what it looks naked eye, you know, that part that is in the shadow is completely dark. I cannot see that portion of the moon at all. Funny question here. Do you two have a podcast? If not, please take this as a suggestion. You're here. This is the podcast, I guess, or at least as close as it gets.
Yeah.
Fortunately for you, this is a series of streams that we do. This isn't a one-off. So you can subscribe to the channel down below, check out our future Sky Observers Hangout episodes, and we'll mention a couple more of those that we have coming up at the end of the stream tonight.
Yep.
But you can also go back and watch any of our old shows. All of those streams are saved as videos on demand on our site. Including, actually I was gonna mention a total eclipse show that we did really just pretty shortly after I had started here. If you wanted to see what a total lunar eclipse looks like, rather than just the partial that we are looking at tonight, they'll link you to that old live stream VOD that we have if you are interested in checking that out. So glad that you're enjoying being here tonight, and I hope to see you at many future shows, because we will definitely be here.
Yep. I'm just moving the telescope around some more, so just go into a few different parts of the moon. Just thought you might enjoy seeing what the telescope could see.
Oh yeah, it is lovely tonight.
There we go. All right.
I was gonna say you can check out our Blue Supermoon show if you want to see more information on details on the moon, but I can't remember. I think we might have been clouded out for that one. I can't remember if we actually got a moon view for that show.
No, I don't think we did.
We did get it for that one? It's
Did
hard
we?
to remember sometimes. An inevitable part of astronomy is getting clouded out sometimes. So if you go back to any of the old live streams and don't actually get to see any live telescope views, I do apologize. Certainly lots of great content in there, but very affected by weather here. So I'm just feeling very lucky that we had such a wonderful view tonight. So great to hear that we've got lots of people seeing it for themselves.
Exactly.
From their houses tonight. Glad that you're learning lots of new stuff with us. Your comments are all very sweet. Thank you all. It's wonderful to hear. And I'm glad that so many of you are getting outside and taking a look at the lunar eclipse yourselves. These kinds of shows are always my favorite. You know, it's wonderful to be able to get to take advantage of this huge telescope we have to look at some really dim objects that are hard to see, right? Really push it to its limits. But I also love being able to look at, you know, these eclipses with all of you live while you're watching with us. It really does make it so much more fun.
And we really do geek out about this stuff too. By the way, how about this? How about this? As a reward for sticking with us And we've got about another 15 minutes of the eclipse at 10:15 because we wanted to stay on for the whole eclipse.
We'll stick around for the eclipse for sure, yeah.
Do we want to maybe reward everybody and just take a quick look at Saturn?
We can always do a quick look at Saturn, of course. They are really close by. Actually, I think just a couple days ago, maybe even yesterday, some folks on the West Coast were able to see a lunar occultation of Saturn even.
Cool.
So they've been really close in the sky recently. So it's a pretty easy switch. I don't know how good it'll look with the full moon so close by, but
Well,
should still be pretty dang good.
We'll see.
We'll have to see and check
If you
it out.
want us to look at Saturn, tell Bella in the chat. She'll tell us. I have a feeling I know the answer to that question, though. So anyway, so I've just been moving around a little bit. So because a lot of you can see the eclipse in the actual sky, why don't I go to maybe a different part of the moon, just cause?
Sure, yeah. And while you pan around the moon and take a look, I wanted to answer another question that we have here. Does the moon have an inner core? We immediately got all caps yeses on Saturn, so that'll definitely happen later.
Okay.
But or we can do it now. Sure.
No, not right now.
Oh, okay. We'll make sure to get Saturn later through the scope for sure. But just adjusting some of the light levels so we can get some of these better details. But the question that we got was, does the moon have an inner core just as hot as Earth? So I think this really is a great question and gets us to think about really the history of the moon, some of the different sort of phases that it's gone through in its life, which I'll talk about as Michelle is providing you wonderful lunar details through the big telescope. So when the moon originally formed, based on our best understanding right now, is that there would have been a really significant impact with the Earth that actually made the moon form. And initially, it would have been actually totally molten, much like the center of our Earth is, right? Now, the Earth, other planets, the moon, all of that molten inner material, right? All of that molten stuff is slowly cooling over time. Now, depending on the size of the body, that can happen faster or slower, right? So with the Earth, we've still got this really molten core in the middle, right? The moon is moving more and more away from that, right? So at first it had a little thin crust that floated up to the top. It was less dense than the rest of the rocks that were still molten in there. And this is actually the light part of the moon that you see. All of these lunar highlands are some of that initial crust, right? And then over time, some of this inner stuff has slowly cooled over time. And I'm not sure if we have actually made it to knowing whether or not it is completely solid all the way through, or if there is still a little bit of molten core. Is there still some molten core left?
I think the consensus is probably, but not completely solid. But it's definitely not anything that can make it out to the surface.
Right. There is not enough molten material in the middle to have active volcanism going on the surface. That's been done for quite a while.
But there definitely is some geologic activity that happens below the surface. The moon still has some stuff going on below the surface. So, it may not be completely solid. It's probably not totally molten like the Earth. It might be some parts of it have solidified for sure.
Ooh, lots of good questions. Love hearing that some of the binoculars folks we're using tonight were recommended on one of our previous shows. So that is great to hear. Our tips are being are getting used again during future shows. That is so wonderful. Some other questions that we have. So both these are kind of related. I'll read both of them off.
Okay.
Does that mean eventually we won't have a moon? Or when will the moon be destroyed? I am scared. Tell me, please.
Okay. All right.
Nothing to worry about, especially not in your lifespan. Our lives are on much smaller scales than the moon. But you can answer this question a little bit more.
So the moon is currently receding away from the Earth at about 1.5 inches a year. So it's about the rate your fingernails grow. That's just a coincidence. The two have nothing to do with each other. However, does that mean the moon will eventually move away from the Earth completely? No, it will not. It will get to a point in the future that it will be farther from the Earth. It will be at about 650 million years from now, it'll be too far from the Earth to completely cover the sun for a total solar eclipse, so we won't have that anymore. The lunar eclipses will definitely still occur, but the moon will never completely go away from the Earth. There is a point at which that will stop. So will the moon be destroyed? No. Will we lose the moon? No. So there you go.
I mean, technically, yes, the moon will get destroyed at some point. The Earth will probably also be getting destroyed at that point.
We're talking like
in
5
billions of
years in
Exactly.
the future. So in other words, don't worry about it.
Everything's kind of on a big cycle of death and rebirth out there in the universe,
Yep.
much like we have here on Earth, right? But again, as a reminder, those are on time frames much different than what we experience here on Earth. So nothing to worry about.
All right, what do we got here?
Couple other good questions coming in. We've got, why doesn't the moon have rings
Oh.
just like other planets?
Oh, well, if the moon got hit by something big enough, it could. Or if something, sorry, I take that back. If something big enough got close enough to the moon where the moon's gravity could pull it apart into bits, that would be rings. That's what happened to Saturn, is something icy got close enough to Saturn that Saturn's gravity pulled that something apart. It might have been a comet or something, or an icy asteroid. And Saturn has rings. Saturn probably has not always had rings.
Right, and some recent estimates have shown that they're actually younger than we might have expected. You
Right.
know, it's not like they've been around for billions of years. We're talking, in the hundreds of millions.
Exactly. If the dinosaurs could point a telescope at the moon, and we're talking like dinosaurs over 100 million years ago, they wouldn't have seen rings. And how long could the rings last? Maybe another 100 million years.
Right, so it could just be that we're really lucky that Saturn has such magnificent rings.
Yep.
Maybe at some point in the past, Jupiter had even bigger rings. You know,
Yeah.
we really don't
Yep.
have so much of a way to know what the
Yep.
early solar system was like. You know, astronomy is working on these huge time scales, and that makes it pretty difficult to really uncover that history so much, right? These things haven't changed a lot since we've started observing them. I had another question that I wanted to mention. We had a request for. Do you know how to pronounce it? Fomalhaut. So this is a star that's in the Pisces constellation, I believe. And I did check, it's a little low for us tonight, unfortunately. We won't be able to observe it. It is up in the sky right now, but one problem that we run into here in the observatory is that we have some limitations on how low of an altitude we can actually point at. It's only about like 10 degrees right now, right?
Yeah, it's too low.
And so we can't really see a lot of stuff until it's up at about 20 degrees. Now, folks that are familiar with this star, they might be familiar with it because of some of the images that we've gotten. I'm not sure exactly through which telescopes, but some telescopes showing like outer rings around the outside of the star, and maybe some, planet formation happening around that star. Those are through much bigger telescopes than our own, and it would just appear as a small regular star through this telescope. So I apologize that we cannot point at that tonight. Unfortunately, it is just outside of the limitations of what our telescope can pull off today.
Yep.
Okay, some great questions coming in. One thing I wanted to mention as we approach the end of this partial eclipse here is, we've been talking about this eclipse, and honestly, we've talked about how folks can go out and observe it. We haven't talked a ton about exactly what is happening out in the solar system for this to be possible. And so we've got a couple of minutes and no extra questions coming in, I wanted to mention this quickly. So eclipses are really all about alignment, right? It's all about these three objects aligning together. That's the case for solar eclipses, for lunar eclipses, and those three really important objects, right, are the sun, us here on the Earth, and the moon. Those are the three objects that come into play here, right? So for a solar eclipse, you get to watch and see as the moon is passing in front of the sun, right? For a lunar eclipse, we've got the opposite arrangement, right? We have the sun, we've got the Earth here in the middle, and then we've got the moon on the opposite side, right? The Earth right in the middle of those two. So the sun over here is casting its light onto the Earth and onto the moon most of the time that it's over here. But in particular situations, when their orbits align up just right, the shadow from the Earth is cast onto the moon over here, sending it into darkness like we are seeing today. And while Michelle is working on getting the settings just right, I wanted to show an object that we actually have on display in the museum right now that does a really good job of explaining this. This is actually very similar to, I'm gonna turn my picture-in-picture off for a second here really quick so you can see the whole thing. This is called a tellurian, and this is basically the old version of what we are doing right here tonight. This is how folks were demonstrating how lunar eclipses were working. And this is on display in our Chasing Eclipses gallery that is still open right now, and you can come see here at the planetarium. And so if we get some closer detailed shots, we can see that this has lots of gears and things working around. The Earth orbits around the sun in this, and the moon is constantly spinning as well, right? And right in that middle hole where you see on the righter image, you set a candle and light that, and it works as the sun, casting this light onto the Earth and the moon on the other side. So you can see the moon's shadow being cast on the Earth during a solar eclipse, and the Earth's shadow being cast onto the moon from the other side around. So if you want to come check this out, you can come see us in person, for those of you that are a little bit more local than our friends joining from Tokyo and Argentina tonight. But this shows you how these eclipses are happening. And actually what this means is that 2 weeks separate from a lunar eclipse, we'll also get a solar eclipse. And I wanted to give a little shout out to the solar eclipse coming up 2 weeks from now. It won't be visible here in the United States, but for those of you joining from Argentina today that I saw, you will be able to catch this this partial solar eclipse. Of course, making sure that you have the proper eclipse glasses like we mentioned earlier. And I will also luckily get to catch this partial eclipse. So if you are in Buenos Aires tonight, see you in about a week and a half. And so if any of you are down there in Argentina on October 2nd, you will be able to catch this solar eclipse. But for now, let's stick to, of course, our lunar eclipse focus that we were so excited for.
Yep. So the eclipse is almost over. So if you, when the moon is passing through the darker part of the Earth's shadow.
Right, the actual partial
Yep.
lunar eclipse is completing.
So I'm just
Getting us concentrated right on that part there.
Yep, so just moving around a little bit, just showing you a few different parts of the moon. But
I had another interesting comment that I wanted to mention here. I wonder what lunar eclipses would look like on other planets.
Ooh.
So there are absolutely other planets out there that could have lunar eclipses happen, right? It does mean that the moon that we're looking at does have to pass behind the shadow of this planet, but some of the other planets out there have got dozens of moons. Planets like Saturn and Jupiter, they have tons of opportunities to see lunar eclipses, and the sun is very distant, the planet is really large, right? It's casting a really big shadow into the sky, and so those can happen pretty frequently there. Now, what their moon looks like might vary pretty significantly, right? There might be some really big ones, there might be some that are really, really teeny tiny from the surface of the planet, so those lunar eclipses can look really, really variable. The color of the lunar eclipse might be completely different than what we experience here on Earth, right? The colors that we see in a lunar eclipse come down to the particular sorts of gases we have in our atmosphere. So it's a great question to think about. You'll also have some opportunities for solar eclipses on other planets too. But, there's not a lot of these other ones that have really been imaged very much, right? We haven't gotten the chance to hang out on all of these other planets and see what these lunar or solar eclipses look like.
Right.
So a lot of it is theorizing.
what do you think? Do you think folks have stuck with us long enough? You think we should show them a little treat?
I think if folks are still around, it's probably time we can go ahead, take a peek at Saturn. Your partial eclipse will be ending in just a moment here. So the rest of the eclipse will be pretty tough to make out. There is technically some stuff still going on up there. There is a dimmer outer part of the shadow where it will still be passing through, but that's a little harder to notice with the eye.
All right, so what we're going to do is we're going to move the telescope, and then I'm gonna have to move the roof a little bit as well. So Hunter's gonna stick around here.
Yeah, I'll hang around here while you get that stuff.
And then I'm gonna have to adjust the camera quite a bit because the brightness of the moon will definitely be different from the brightness of Saturn. So Here we go. All right, ready?
Yeah, go ahead. We will lose our view here for a second. You might see the telescope moving a little bit behind me here.
Okay, I'm gonna move the roof.
All right, we're gonna move the roof here. Apologies, I'm gonna turn the sound off here for a second.
Is that good?
Yeah, looks great. So the roof is really loud. It is the original roof from 1977, and so we do like to keep it quiet when that's happening. One thing I want to mention while Michelle gets our view of Saturn ready to go is some future shows that we're going to be doing, some future episodes of Sky Observers Hangout. So something that we have coming up, we are going to be joining Southern Illinois University down in Carbondale, Illinois for their annual Star Party. That is an in-person event. If there are any folks from Southern Illinois or the surrounding area joining today that would be interested in coming and joining us in person, Bella's going to send a link to the in-person event information. But I also wanted to mention that we will also be hosting a live stream on their Solar Steam YouTube channel. I'll be hosting that. It'll be really similar kind of vibes to what we run here at Sky Observers Hangout, and it would be wonderful if folks could come and join us on October 19th. There will be information about the stream posted on SIU's Star Party website coming up. We're also looking at some potential dates for this comet Atlas that is right now making its close pass of the sun. The date for that is still a little unknown, and it'll depend on how this passing of the sun goes. This comet has never approached the sun so closely before, so it could break up. We will do our best to show that, but keep an eye on our social channels to see if when that might be happening. That'll be happening in October, in about a month's time if we are able to catch it. So hit the subscribe button down below if you want to see when that is coming up, and make sure that you are seeing that, observing that comet with us. And then, of course, wanted to give a shout out to that total lunar eclipse that we've got coming up on March 14th of 2025. Now, I will say you will have to stay up pretty late with us for that one if you are in a similar time zone as we are. I think that one's at like 3 o'clock in the morning, something way late into the night. So hopefully you can all join us for that show on March 14th of next year as well. So a couple to look forward to in the future. Now, I know you guys have been just desperately waiting to see this view of Saturn as Michelle gets it in focus right behind me, and it is already starting to look pretty nice. So I think I'm going to switch to our telescope view here tonight. Here it is coming into view.
That's pretty good.
It's not a bad view. So you might notice we do have a black and white camera on the telescope tonight. You might also notice that the rings are pretty tough to make out. They're currently in the act of tilting away from us, right? So you can imagine if my hand's Saturn here, right? Sometimes it is tilted towards us like this, and we see these big rings all around the outside. Well, right now, it is tilting towards being basically side on by spring of next year is when it'll hit really side on. So we can just barely make out the gap between the front and back rings here with our telescope. That does look pretty good. This telescope always blows me away. I've seen Saturn, I can't even tell you how many times through this thing, but it is always exciting. Well, especially when you get those really clear moments of atmosphere and it starts to hit really, really crisp and nice. You can see some of those cloud bands on Saturn. You can even see the rings passing in front. And you can even make out, if you look, I don't know if you guys can see this online. I know the resolution might not be quite as clear as what I can see here in person. Towards the edges of the rings, you can see a little black dot on either side. That is the Cassini division, which you can barely make out with how tilted the rings are right now.
So
here's a snapshot. Yeah, I can see the snapshot, yep. So Michelle's pulling up a snapshot that she took.
So there's a quick snapshot.
There you go. Yeah, you know, the live view, you could really get some nice little spots here every once in a while. So I see we've got lots of excitement for Saturn in the chat. Good. I'm glad that we switched to it here to end the night off. It's always a nice little target to finish the night with. I do want to answer one last question that we have. Is it true Earth is the only planet with a total solar eclipse due to the fact that it's the perfect distance from the sun and size of moon? So one thing that I will say, I do not believe that it is the only one where we have total solar eclipses. Actually, I know it's not, because we can see shadows from other moons being cast onto planets like Jupiter. So they are experiencing a total solar eclipse in that location. The sun's pretty small there, and they've got lots of pretty big moons, much bigger than even ours. So they do experience total solar eclipse. What is particularly special here on Earth is how similar in size the moon and the sun appear. So the view that we see, where we get this magnificent display of the corona around that dark circle of the moon, is honestly pretty unique to the Earth. I don't know if there's any other places where the exact sizes are so close to each other like they are here on Earth. So I do think that makes them pretty darn special. Oh, we have one more comment coming in here. We have some clouds, but I was able to see some of the eclipse. Thanks for encouraging us to go outside. So glad to hear that you were able to make it out and view it, even through some of the clouds. And I'm glad that we had a nice clear view to offer tonight. Hope everyone is enjoying the lovely view of Saturn that we have to end things off as the lunar eclipse is finishing. Trying to get my final little view of the moon here if I can see it, and a big telescope in the way tonight. If anybody has any final questions for us, make sure to send those in now. We'll be wrapping up soon now that the partial lunar eclipse has ended. Snap a good one.
There was a
little break in the atmosphere. I know, there have been a few really nice moments when I was looking close. Really demonstrates how the atmosphere influences the views that we get through our telescopes, right? Well, a couple of things that I wanted to mention before we go here tonight as we look at this beautiful view of Saturn. Other than subscribing to the YouTube channel to keep up with Sky Observers Hangout, but also any of the other wonderful astronomy content that Public Observing, but also all the rest of the awesome Adler team that we have. Subscribe to the YouTube channel. You can also check us out on our Facebook group at Scopes with the Adler if you would like to keep up with not only the Sky Observers Hangout streams, but also all of the in-person telescope events that we do. If you're joining us from a closer area, if you're from here in Chicago, you can check us out there. And one thing that we always love to encourage at the end of the show is if any of you snapped some great pictures of the lunar eclipse tonight, and you want to share those, with our big community, you can share those on the Scopes with the Adler group or any social media platform that you use. You can tag us. We always love to use the hashtag #lookup when we are posting our observation logs for the night. So we love seeing all of the images that you guys were able to capture right alongside us tonight. And a couple of final things. Bella will post a link to a feedback survey in the chat. We love getting to hear feedback from you guys, improvements that you think we could make, potential future show topics, all kinds of things. So if you've never filled it out before, we'd love to hear from you for the first time. If you're a frequent Sky Observers Hangout viewer, we are always interested in hearing your feedback, of course. Michelle, is there anything else that you wanted to leave our folks with?
Thanks for joining us. This is really a lot of fun, and it's really fun to just sit here with the joystick controller and move the telescope
and look around, exactly.
and just look around at other stuff. And it's just like putting your eye up to it. But please remember that we do have the observatory open if it's clear out on Wednesday nights. So those of you here in the Chicago area, yes, we will be open tomorrow night starting at 7:30. So if you want to come down, please say hi. Please come. I'll be here. Dylan will be here. So you want to come and say hi again? Here's Dylan again. And so we'll be here tomorrow night, and we'd love to know that you were watching us. And I know that Hunter was mentioning future shows, but yeah, hopefully the Comet will stay
hopefully
together.
Comet Atlas, if it sticks together, we'll be viewing that in October.
We got
Star Party on October 19th.
Yep.
And then looking forward to the total lunar eclipse on March 15th, 2025.
And the show on Jupiter. So we're going to do a show about Jupiter and in December. So we've got that in early December. Again, keep an eye out for our social media feeds for exactly when we're going to broadcast that, because it kind of depends a little bit. We try to do it on nights that are clear, and we
right, we do our best to get clear skies.
We often don't know if it's going to be clear till the day before, so we have a couple dates picked out, but we'll let you know when that is. So Man, this is a lot of fun.
Well, this has been a great time. It's always especially wonderful when we have a nice view through the telescope.
Yep.
But it is also wonderful to be able to just hop online, chat with all you astronomers at home. Thank you so much for all of the wonderful questions and comments and observation logs that you were sharing with us throughout the night. Thanks so much to the behind-the-scenes stars today, Geza answering the tough questions. I bet he put the cratering impact rate and stuff that we don't know right off the top of our head. I can almost guarantee he was in the chat putting those things in there. Bella feeding us all the questions for tonight. Dylan getting our wonderful view of the moon through the sea star. So thank you all so much for joining us. I will leave you with this lovely view of Saturn for a little bit longer, but we are going to say goodbye for the night, and thanks so much for coming out and joining us. All right, bye everyone.
Bye everyone. Good night.